All right, welcome to Mr. Jensen's math class. In this video, probably won't be a very long video, but we're going to look at finding limits by dividing. Limits are something that are in calculus that are important to find, and usually it's an issue when the function as x approaches a value. For example, if you look at number 13, the value as x approaches 1. Notice we're going to get a 0 in the denominator. That's always a situation where something fun is going to happen. So let's look at number 13 to start. Okay, and first look at what we have here. Suppose f of x and g of x agree in all but one point. If the limit of f of x exists as x approaches c, then the limit of g of x will also exist as x approaches c. What that basically says is we've got the limit as x approaches 1 of x cubed minus 1 over x minus 1. Remember that the first thing that you do when you go to find a limit is you substitute the c, in this case, which is the 1, in place of the x. And when we do that, we have 1 cubed, which is 1 minus 1 over 1 minus 1 in the denominator, and that gives us 0 over 0. 0 over 0 is an indeterminate form, which means we can't determine anything from that, of course, other than the fact that we have more work to do. Now, you remember, hopefully, from pre-calculus from Algebra 2, that if you put 1 in for a polynomial and get 0, like what happens in the numerator, that means that x minus 1 is going to be a factor. Obviously, x minus 1 is a factor of the denominator. Putting 1 in for the numerator gives us a 0 in the numerator. Therefore, x minus 1 is also a factor of the numerator. If I remember how to factor a difference of two cubes, you'll recall that the factor that's left in the numerator is x squared plus x plus 1. Now, in this case, what's happening is we have the limit as x approaches 1. Remember that as x is getting closer and closer and closer and closer and closer and closer to 1, but does not actually equal 1. So as x is getting closer to 1, x minus 1, I'm sorry about that, x minus 1 is not 0, x minus 1 is not 0, and so I can tell you that x minus 1 divided by itself is going to cancel out. And what that will leave us with then is the limit as x approaches 1 of x squared plus x plus 1 with a denominator of 1. Now, when I substitute the 1 in for the x again, let's use a different color. When I substitute the 1 in place of the x again, we're going to have 1 squared plus 1 plus 1, which is going to equal 3. Therefore, the limit as x approaches 1 of x cubed minus 1 over x minus 1 is equal to 3. Let's do another one. Look at number 14. We have the limit as x approaches negative 3. So again, I'm going to substitute negative 3 in place of the x in the x squared plus x minus 6 and for the x plus 3 in the denominator. So that's negative 3 plus 3. Notice we're going to get 9 minus 3 minus 6 in the numerator. That's 0. And again, we have negative 3 plus 3, which is 0 in the denominator. We have the same situation. Putting negative 3 in for x in both the numerator and the denominator gave us a 0. So not only do we know that x plus 3 is a factor in the denominator, we know that x plus 3 is a factor of the numerator because as x approaches negative 3, the function equals 0. Negative 3 is a 0, therefore x plus 3 is a factor. Factoring the numerator, x squared plus x minus 6, is going to be x plus 3 times x minus 2. Notice again, we have an x plus 3 and an x plus 3, both in the numerator and denominator, so they can cancel. They will divide out to 1 as long as x is not negative 3. And we're talking about x is getting closer and closer to negative 3. So now I have the limit as x approaches negative 3 of x minus 2 over 1. Substituting, I apologize for that, substituting the negative 3 in place of the x, we now have negative 3 minus 2. I don't need to rewrite that. We have negative 3 minus 2 is negative 5. Therefore, the limit as x approaches negative 3 of x squared plus x minus 6 over x plus 3 is equal to negative 5. Now, students will often ask me, how do I write that as an answer? I recommend that you rewrite the limit as x approaches negative 3 of x squared plus x minus 6 over x plus 3 is equal to negative 5. And that's the best way to write your problem and your solution. Okay, so just a couple more. It's a bit repetitive, but let's look at these next couple, 15 and 16. Obviously, this is part of a larger calculus set that I have, and please, stay tuned for other videos, watch other videos for more calculus. But the limit as x approaches 0. So again, if I put 0 in for x, 2 times 0 over 0 squared plus 4 times 0 is again going to give us 0 over 0. So I have the limit as x approaches 0. Since putting 0 in for x gives me a 0 in both the numerator and denominator, again, I know that x is a factor. My numerator is 2 times x. My denominator, I can factor out the x, and I'm left with x plus 4. And again, x divided by x is equal to 1. As long as x is not 0, and again, we're approaching 0, we're not equal to 0. So now I have the limit as x approaches 0 of 2 over x plus 4. If I substitute that 0 in for x, I have the limit. Oh, I don't need to rewrite the limit again. I'm going to have 2 over 0 plus 4. Notice I'm putting the 0 in, so I don't need to rewrite the limit. So that's 2 over 4, or 1/2. And again, the best way to write my solution there would be to write that the limit as x approaches 0 of 2x over x squared plus 4x is equal to 1/2. Okay. I welcome you to keep watching. If you feel like you've got a good grip on this, you can move on to the next video, but I'm going to do a couple more. Notice, again, substituting 5 in for x. I have 5 minus 5 over 5 squared minus 25 is going to again give me 0 divided by 0. These problems are all set up to do that. Again, I'm going to factor both my numerator and my denominator. Now, I'm going to factor the denominator first because I notice something in the numerator here, but my denominator is going to be x minus 5, x plus 5. In this video, I'm not going over how to factor. Make sure that you're good with your factoring, or look for other videos on factoring. I am going to clean this up just a little bit. Now, notice my numerator is 5 minus x instead of x minus 5. I can factor out a negative from that. So I have the negative x minus 5. So now, when I cancel x minus 5 over x minus 5, or I divide out x minus 5 over x minus 5, leaving me 1. Those are both become 1s. Now I have the limit as x approaches 5 of negative 1 over x plus 5. Substituting the 5 in for x, I get negative 1/5. So again, the limit as x approaches 5 of 5 minus x over x squared minus 25 is equal to negative 1/5. Okay. I like the next one, number 17. If you looked ahead to that one, okay. Oh no, we have e to the 2x and e to the x minus 1. Again, notice if I put in the 0 for x, I have e to the 0 minus 1, e to the 0 minus 1. Looks like those are the same thing, and we'll get 1. But remember, e to the 0 is 1. 1 minus 1, 1 minus 1. We get 0 over 0, which is indeterminate. Now I'm going to write and erase if that's okay here, but remember that e to the 2x is equal to the e to the x squared. okay? Because if I have a power to a power, I would multiply those exponents. X times 2 or 2 times x would give me the 2x. In calculus, I need to be able to split that and go the opposite direction. So if I think of this as e to the x squared minus 1 over e to the x minus 1, what you should notice is that that numerator is a difference of squares. E to the x minus 1, e to the x plus 1 over e to the x minus 1. And those two are going to cancel out as long as x is not 0. Because we know that when x is 0, the function's undefined. In fact, if you've studied this yet or pay attention to what's coming up when you graph these functions, what you'll find, there's a hole in the graph. It'll look like a normal curve, especially if you graph it on the calculator, but there'll just be one tiny little hole punched in. Where is that hole? Well, now that I have the limit as x approaches 0 of e to the x plus 1, putting the 0 in for x gives us e to the 0, which is 1, plus 1 is 2. So again, the best way to write that, the limit as x approaches 0, e to the 2x minus 1 over e to the x minus 1 is equal to 2. And again, what you'll find is if you graph the function f of x equals e to the 2x minus 1 over e to the x minus 1, you will get a curve. Graph it with the calculator, but you'll notice that there's going to be a tiny little hole. There's going to be a hole at the point 0, 2, because as x approaches 0, y is approaching 2. So that's something to look forward to as you go on forward. Now, if you look at number 18, a little bit more exciting because I don't have a single factor in the denominator or the numerator like all my previous problems have had. This time, if I put in 2 for the x, I have 2 squared, which is 4, plus 2 times 2, which is 4, minus 8. So 4 plus 4 is 8, minus 8 is 0 for my numerator. I know where this is going. Putting in 2 for x in the denominator, 2 squared is 4, minus 2 is going to give us another 0 over 0. Again, knowing that we get 0 in both the numerator and the denominator by putting 2 in for x tells us that x minus 2 is a factor of both the numerator and denominator. A lot of students don't like factoring trinomials. Get over yourself, get better at it, work on them. But it's a lot more helpful if I know one of the factors. One of the factors is x minus 2. Therefore, the other factor in the numerator is x plus 4. The other factor in the denominator is x plus 1. Again, x minus 2 divided by x minus 2 will equal 1 over 1, as long as x is not 2. And so now we have the limit as x approaches 2 of x plus 4 over x plus 1. So 6 over 3 is equal to 2. So again, the limit as x approaches 2 of x squared plus 2x minus 8 over x squared minus x minus 2 will equal 2, which again means when you start graphing these, that this function will be the same as the function f of x equals x squared x plus 4 over x plus 1, except that when x equals 2, we're going to have a hole in the graph at 2, 2. X is 2 from there, y is 2 from there. Okay, so I hope that that helps you a little bit finding limits by dividing. Thank you.